On behalf of RBCS and STPCon, welcome to this webinar on myths of exploratory testing. I am Rex Black, president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I am the author of 14 books on software testing, including the bestseller Managing the Testing Process, at least bestseller for testing books. It is. Before we start, feel free to submit questions at any point during the webinar via your webinar interface. I will be answering them at the end. There is no need to ask for presentation copies. The PDF of the presentation is posted on our website in the basic library. And by attending this webinar, you are automatically registered for the free e-learning drawing, so check your email over the next couple days. I hope you enjoy this free webinar. We do these free webinars as a service to the software testing community because at RBCS, we are not just for-profit company. If you feel these webinars demonstrate insights into the kinds of testing problems you face, please make RBCS your first choice when you need consulting, expert services, or training. Now on with the show. So today we'll talk about myths of exploratory testing. We have some famous American explorers there, Lewis and Clark and Sacagawea, if you're wondering what that picture is about. So first, what is exploratory testing? Exploratory testing can be defined as a technique that uses knowledge, experience, and skills to test software in a non-linear and investigatory fashion. So that's a pretty widely shared definition of exploratory testing, at least an intuitive one, but there's a lot of myths around it. Where did it come from? What is it good for? Is it the one true way of testing, or is it just a random bug hunt of some kind or another? Can we do without it? So let's see if we can get some clarity on those questions. So there are a couple of sort of fundamental concepts in testing. One is this idea of a test basis, and the other is a test oracle. So your test basis is what your tests are based on, naturally enough. It's the thing from which you derive your tests. And the test oracle is the thing from which you derive your expected results. They are not always identical, though there's often overlap between them. So for example, if I have user stories and acceptance criteria, then generally the user story and its acceptance criteria will be the test basis in agile testing, and the acceptance criteria will be the primary test oracle, though other test oracles include things like previous versions of the software, competitive software, and so forth. So that would be, if I take a user story and its acceptance criteria and analyze it and turn it into tests, ultimately, that is sort of the opposite of what exploratory testing is, because I'm proceeding from a very clearly defined test basis, with clearly defined test oracle, and generating the test from it. Whereas in exploratory testing, my test basis and test oracles are primarily my skills, knowledge, and experience. Now, generally, that any form of testing where the primary test basis and primary test oracles are skills, knowledge, and experience is referred to as experience-based testing. And sometimes that experience-based testing can be rather linear. It follows a checklist, for example, which was developed over some period of time based on experience. That would be linear and not investigatory because it would fall within some clearly defined parameters. But if we have experience-based testing that is nonlinear and investigatory, then we can call that exploratory, because we are designing, implementing, and executing the tests all at once. Basically, we may well have a defined set of test conditions that we want to cover, but the specific things which we test are going to be generated as we go based on what we see from step to step, hence the name exploratory. Now, in a survey back in a couple years ago done by the ISTQB, 2/3 of test teams reported using exploratory testing, which was higher than any other technique other than use cases. Use cases were reported at 70%. Now, you could say, well, that means that exploratory testing is really great and powerful, but I think that may also say that a lot of people don't have proper training in proper test design techniques too. So it's hard to really know what the reason for that is. Um, that's certainly something that I think would bear further investigation. But be that as it may, this is certainly one of the more prevalent forms of software testing, and exploratory testing can be considered a form of validation because the tester, assuming that the tester has the proper skills, experience, and knowledge, is thinking about what the user and customer expectations are. What is fitness for use or fitness for purpose, as J.M. Duran put it in one of his in his classic definition of quality. Now, in contrast, if we think of Phil Crosby's definition of quality, which is conformance to specifications, that's verification. If we're testing in a way that we verify against specifications, then that's not a form of validation, because we're looking at, does it do what we said it was going to do, not is it fit for use or fit for purpose. Now, in a properly managed testing operation, you need both verification and validation. So I'm not saying one is greater than the other. They are both of equal value. If you go back to the example I gave of taking a user story and its acceptance criteria and translating it into tests, that's verification, because that's a written specification which has now become the tests that we are running. And what those tests will tell us is, does the software conform to its specification, versus the exploratory tests, which may tell us little or nothing about conformance to specification, because the specification may not even be consulted by the tester in the process of generating the tests. So we'll come back to what exploratory testing is and should be, but I want to fulfill the promise of the title and bust a few myths here before we get into that. So there is the origin myth of exploratory testing, which is exploratory testing was invented in the 1990s in Silicon Valley. Now, that's probably where the name exploratory testing first got hung on it. If I remember properly, it's in Kem Kainer's book, Testing Computer Software. I believe he used that phrase exploratory testing in there. So that's where that term gets put on it. But I would guess that it was probably actually invented by the first person to write and run a program. That to some extent they decided, I'm going to play around with this thing a little bit and see what it does. It certainly was in use in IBM starting in the 1960s, because there is a specific mention by Fred Brooks in the Mythical Man Month, his book about writing the operating systems for IBM in the 1960s, of independent test teams. And it's difficult to imagine that those independent test teams were not using exploratory testing as a technique. Now, Brooks worked with a fellow named Glenford Myers at IBM, and Glenford Myers later wrote a book called The Art of Software Testing, which was published in the mid-1970s. And in that book, he described something that he called error guessing, which, if you read his description of error guessing, it sounds a whole lot like a form of exploratory testing, one which is focused on using the knowledge of mistakes and defects and failures as the primary thing upon which you are deriving your tests. So another myth of exploratory testing is the completeness myth. And this is common in organizations that have very immature software engineering and software testing practices. And the myth is, well, if we just play around with the software, that'll be fine, and we can make sure it works before we ship it and put it out there, and everything will be peachy. And of course, that's not at all the way that works. In the long run, that ends up being self-dispelling, that myth, because people start to realize, wow, we're shipping a lot of defective software. Unfortunately, what often happens before people come to dispel the completeness myth is that they dispel the testers who are involved, thinking that, well, if these testers were only competent, they would be able to find all the defects before we ship it. Now, why does this pop up? Does that mean that there are no smart people involved in software engineering? Well, no, but the problem is that in computer science and computer and software engineering courses in colleges, there's generally very little education about testing and what it can or can't accomplish. Um, I had someone tell me today at the conference that they had my book, Managing the Testing Process, as a text in their university software engineering, and I was just stunned by that. I was like, wow, really? Okay. I guess there are some exceptions to that rule, but as a general rule, it is quite possible to graduate from college with a software engineering degree, and you don't hear a whole lot about software testing. I got a computer science degree from UCLA, which is a good engineering school for sure. We had to take a course in software engineering, which is sort of the industrialization part of our education, 10 weeks long. In 1 week, we talked about testing. So there were three sessions where we talked about testing. 2 of those 3 sessions were about unit testing. And then there was 1 hour spent talking about integration tests and system tests and so forth. And I remember very little of it, but even if I could remember it, I'm sure that what was taught was by no means adequate to summarize everything that one would need to know to be a professional tester. I do remember the professor making this sort of snide comment about, yeah, in some organizations there are these rather odd people called software testers, and they find a lot of bugs, and but you don't have to worry about that. I ended up being one, so there you go. Yeah, we have this gap in education, and we also have the sort of gap in the standard of what it means to be adequately educated to be a software engineer. It's difficult to get people to even agree on that. To some extent, there are certifications out there that fill this gap to some degree, but there's a lack of universal acceptance of those, and so it really, what a tester knows, what a software engineer knows about testing can be pretty limited. So then you also can get the sufficiency myth, which is basically people who believe, okay, we had this dude come in and he is a mighty Jedi warrior of exploratory testing, and this person has taught us to find every bug that can matter. So without getting into some discussions about mighty Jedis and whether such things exist or not, or just in movies, let's look at a study here, because facts are always good, empirical evidence always good. Microsoft did some studies where they actually took their testing groups on particular applications and split them in 2. And one group was allowed to only do exploratory testing and other kinds of reactive testing strategies. In other words, testing strategies that did not involve pre-designed tests, while the other groups would only run pre-designed tests, including automated tests. And what they found was that the set of bugs found by the 2 groups were partially but not fully overlapping, meaning that there were bugs that were found by exploratory testing that would not be found by pre-designed tests, and vice versa. So much for the sufficiency myth, right? If the bugs that were found by only by the pre-designed tests would not be found if you only used an exploratory test. One of the ways I like to think about just testing and sequences of testing is like a water purification system. And here we see this nice animated model that shows the intake of lake water passing through a series of filtration processes, ultimately being chlorinated and made safe to drink and stored and then distributed. So each one of those steps in that treatment process brings the water a little bit closer to drinkable, but you really wouldn't want to break in at any step along the way other than the tap and start drinking it. Surely, you would not want to drink directly out of the lake unless you actually wanted to get Giardia. Which, having had my father get Giardia, I can tell you that is not something you want. And, you know, water filtration systems aren't perfect either. You know, there's always some amount of particulate matter left in the water at the end. And similarly with testing, you never get 100% defect detection effectiveness. It's two fundamental principles of testing, right? That testing can show the presence of defects but cannot prove their absence, and then the fact that exhaustive testing is impossible, right? So the reason that we can't prove the absence of defects with a set of tests is because there is no finite set of tests which is exhaustive. Okay, so the flip side of that myth, the sufficiency myth, is the irrelevance myth, which is the we don't have to worry about exploratory testing or indeed any form of validation at all. So we have test-driven development or acceptance test-driven development, behavior-driven development, maybe a mix of two of those, maybe all three, but it's usually either ATD or BDD, not both. And therefore, people sometimes believe we have 100% confidence in our software. Now, lest you think that I am making this up, I would invite you to go and crack open Kent Beck's book on extreme programming. And if you search around in that a little bit, you will find Beck makes an extraordinary statement about the effectiveness of test-driven development, where he says that if I have a set of unit tests, automated unit tests created using TDD, I can make any change I want to the software that is covered by those tests and have 100% confidence after running those tests that I have not introduced any regressions. Now that is a claim that a set of tests, in this case unit tests, can prove the absence of defects. Now that principle of testing, that testing cannot prove the absence of defects, goes way back to Eggers Dijkstra, if I'm remembering properly, and no one has yet been able to refute that. There were some attempts at one point in time to use mathematical things called proofs of correctness, which were kind of hot when I was at university in the 1980s, and that ended up going pretty much absolutely nowhere. So tests are certainly by no means mathematical proofs of correctness. Excuse me. And notice that what we really have, we're talking about TDD, BDD, ATDD, these sort of things, is verification. These are tests that are either derived from a specification or which, in the case of TDD, are themselves an executable specification. Now, if you go back to computer science and you talk about the amount of bits needed to encode a description of another set of bits, there are some rules about how much information must be there to describe that other thing. So if we think of the specification as describing the code and the behavior of the code, the discrepancy in size between those two things is so large that it's obvious that no set of specifications, even the best written one, can be a complete description of any set of code. So this idea is just, it's impossible, right, from an information theory perspective. So Brian Merrick was nice enough in his final days as a tester working within the Agile community to come up with this idea of the testing quadrants, which for organizations who are doing Agile gives a nice way of thinking about achieving a proper balance between verification on the left-hand side of the quadrant and validation on the right-hand side of the quadrant. If you're not in an Agile world, though it's less and less people as time goes on, the test types and test levels that are discussed in the ISTQB Foundation syllabus are a good way of making sure that you're not forgetting things, and that would also include doing experience-based testing. Now, another myth of exploratory testing is it's not manageable. There's no way to manage it. There's no way to capture test coverage. It's just this wild, chaotic bug hunt. And it certainly can degrade into that. But you can get logging tools, for example, Rapid Reporter being one of them, that can capture what you've covered and what you've seen and what kind of defects have popped up and what you expect to do next. And what kind of things the stakeholders may need to hear about, and questions that you might have, like, did this do the right thing? I don't know, because my test oracle is imperfect, as they often are. Did I use the right environment? Maybe I didn't have the right environment available. Maybe I didn't use the right data. Maybe I need to come back and look at data again. Screen captures, video clips. So it's certainly quite possible that if we time box the exploratory testing sessions and put a nice clear scope around the testing to be done using some sort of test charter, which is just a set of one or more test conditions together with a time limit. This allows an amount of management and direction that's certainly comparable to pre-designed scripted tests. And there are plenty of organizations that are doing FDA-regulated medical devices and pharmaceuticals and so forth that have audit standards that they have to meet that are able to do exploratory testing. I've talked to people working in that space who use it. It's just they have to be very careful about the record keeping. Okay, so having busted some myths here, let's come back and talk a little bit more about exploratory testing and reactive strategies in general. These are useful in any situation because, as I said, the requirements are never going to be perfect. So the idea that we can, based on any sort of analysis or model or checklist, predefine a set of tests that is going to be 100% adequate for the software before we've even seen the software is really not a realistic expectation. And certainly with agile projects where you have an emphasis on limiting documentation and being willing to accept change, making sure that some of your testing is done in a reactive way that doesn't involve creation of a lot of paperwork in advance effectively is a smart thing to do. But that said, you want to make sure that you are using other types of strategies like an analytical risk-based strategy, analytical requirements-based strategy, and regression-averse strategies through, say, heavy automation of your regression tests and so forth, rather than just relying on the exploratory testing by itself. So if you're going to do an exploratory test, it's a good idea to do some analysis to produce your test conditions that go into the test charter, along with assigning some sort of time box, 30 to 120 minutes around that. That is something that can happen in an agile project as part of a user story refinement session, as a way of having a discussion about what should we test. And the design, implementation, and execution, as I said, would occur all at the same time, guided by the charter. Now, sometimes people think, oh, well, we're doing exploratory testing and that rules out any sort of formal test design techniques, but that's certainly not the case. If somebody's doing an exploratory test, they want to try to identify boundary values or build a state model or something like that, then by all means, it's a good thing to do. Excuse me. So as I said, time boxing your test sessions prevents overlap, helps prevent the runaway tester problem, though in some cases, you know, it's more successful than others. I've had a number of testers work for me that varying degrees of manageability. Now, the time allocated to the session should include things like setting up the tests, getting the software loaded, of course, designing and running them, logging the results, and investigating any bugs that are found. And you want to make sure that you are recording the planned session time versus the actual time. Now, the sessions can be one where one is familiarizing oneself with the program, or getting into a specific feature a little bit, or maybe even going really deep into a feature if it's considered to be high risk. The amount of documentation that you see in these charters can vary. Some cases you get the actor, the intended user, how to set up, preconditions, prioritization, references to test basis and test oracle, documentation, activities, variations to try. Now, to the extent that we start to document too many of those kinds of things, we move out of a purely exploratory mode and into a more predefined mode. Now, one thing that I would definitely say you want to have ready to go before the exploratory test sessions start is your test environments and your test data. You don't want to be squandering a lot of time trying to load tables into a database or anything like that. And this, means that you do have to think a little bit about the sequencing of your exploratory test sessions such that they are ones that use common environments and use common data happen at common periods of time. So since we are relying on our skills and experience as a primary test basis and a primary test oracle, having some questions and heuristics in mind to jog thought is a good thing. So within the confines of the charter, it is still possible for the tester to get lost and waste time basically on irrelevancies. So keeping this question of what is most important to discover and explore is in top of mind is a good thing to do. If what we are trying to do is find as many defects as possible through our exploratory test, which may be an objective, then another thing to keep on the top of your mind is how might the system fail? What behaviors is this thing exhibiting right now which are suspicious and make me want to poke and prod more in that place? The does versus should happen dichotomy. What is happening? What should happen? Definitely when you don't want to take the program at its word, right? You try things. If this happens, then what's supposed to happen? This can be particularly useful in testing of mobile apps. Mobile apps are subject to a tremendous amount of interruptions. There's a lot of other stuff going on the phone while your mobile app is running. I'm dealing with something right now. This is a periodic problem with my phone where if any of the connectivity states change on any one of the radios, the Bluetooth resets and I lose my Bluetooth connection. And this can happen multiple times in the space of 10 or 15 seconds. It's exceptionally frustrating in the middle of a phone call or listening to a podcast. I just wish that somebody had bothered to test the Android OS and see what do resets of one radio affect the other radios. So interruption testing like that has always been something of a challenge, and there's always been a lot of discussions about how to test real-time systems that are subject to a lot of interrupts, and exploratory testing provides a way of playing around with that because it is, of course, yet another infinite test space effectively of the different possible things that can happen. As I mentioned before, the focus really does need to be on validation, not verification. So will the customer or user be satisfied? And when you have testers who have a different background from the customers and users, techniques like user personas can be very useful in terms of helping people keep the customers and users in mind. Another thing to not to forget about, especially true with mobile apps again, installation, upgrades, deinstallations, those sort of things, those don't get tested as much as they should, and it's a good practice to include some of that in there. Have some charters, test charters that look at the different variations there, especially when there are multiple upgrade paths and when the application accumulates a fair amount of data from one version to the next. You can get, and I have seen situations where configuration data from earlier versions is not 100% compatible with newer versions, and that can create situations where you actually have to delete the old configuration data, and all that configuration data is lost. And it's just, of course, extremely frustrating for users. Now, in terms of what kind of skills, experience, knowledge can we use with exploratory testing? Well, certainly the system under test itself, any knowledge you have of that. any knowledge that you have of the business domain, the problem to be solved for sure. How do people use the software? How have you seen software fail? Those are all, good sources of ideas. I've heard people talk about testers deriving inspiration from things like their experience as a classical musician. Now, I can imagine that that would teach discipline, and then discipline is always useful, but it's difficult for me to draw a straight line between what you know about music and testing software, unless, of course, you were testing software that happened to involve music, like, say, an audio application like Audacity or something like that, where it would be, of course, the business domain, right? Heuristics, testing of boundaries. If you have persistent data in a database, the CRUD acronym: create, read, update, delete. I'm going to make sure that you've done those adequately. Different kind of configuration variations, especially more obscure ones, as I mentioned, possible interruptions. Another good thing. Different use cases that someone might try to carry out, ways that they might try to carry out a particular goal. All of those would be potentially useful sources of ideas. But again, you have to go back to the what is most important, because it is possible to get defocused during these exploratory testing sessions and ending up, testers end up wandering off into less important areas of the software. And they may well come back with a big pile of bugs and be quite proud of themselves for doing so. But then those bugs end up getting deferred because people look at them and say, no one's ever going to do that. No one's ever going to go there. And that ends up being frustrating for the tester, of course, but testers sometimes forget that that's also very frustrating for the stakeholders, the developers and product owners who are getting this irrelevant information, right? One of the stereotypes that developers and product owners sometimes have about testers is that we're this sort of nitpicky, beside the point cost center. And I think that's not a fair stereotype 9 times out of 10, but 1 time out of 10, I think that can be a fair stereotype. And developers and product owners who have had time wasted by testers on those sort of things, who pester them with defect reports that really are very low importance, and meanwhile very significant defects are popping up in production, it does undermine the credibility of the test team. And I am aware of multiple situations where test teams were actually dissolved entirely because that level of frustration within the product owners and developers reached a point where it was unsustainable. So again, this can be less of an issue with pre-designed tests, this issue of wandering off into irrelevant portions of the application, because the pre-designed tests are subject to review. If you have a proper review process, you can make sure that you decide, okay, yes, the emphasis in this test is correct. But in exploratory testing, that's a decision that has to be made in real time by the tester, him or herself. Now, some tests are just natural fits for exploratory testing. So I, at one point in my career, had to test a device, a consumer electronics device, so it was a hardware software system that allowed access to the internet. And it allowed access to the internet for people in different ages, and those different ages had different levels of filtering turned on. And we had to check for whether the filtering was working with these different configurations. Really a situation that was, I wouldn't say impossible to pre-design the test for, but certainly not a good fit for pre-designed tests, because you have to sort of follow your nose, if I can put it that way, to find where the weaknesses are in this filtering software. It's not possible to predict until you've started to poke around with it and see, okay, yeah, it's got weaknesses here or here. The way that we actually did this exploratory testing charter that you see here was given to all those testers on my test team who were willing to participate in the test. At the beginning of the day, I told them that we were going to test filtering, that if anybody was concerned that they might be offended by some of the things that they would see in the test lab that day, that they were free to leave, take the day off, paid day off, and that wouldn't be held against them. I just didn't want them to be exposed to anything that they didn't want to see. Now, interestingly, nobody left. And everybody was intrigued, and I told them, okay, well, here's your charter for today, and your objective is in the course of the next 2 hours to come up with your own top 10 list of the most obnoxious, objectionable, pornographic, lewd, obscene, or violent filter fails that you can find. And I said, everybody's list has to be different. There's no fair overlapping. So first one to the nasty website gets to have it on their list. And then after lunch, I brought the marketing folks up to give them a little show and tell, because they had had some trouble relating to these defect reports that I was filing that were saying things like, filtering allows pornographic websites through, filtering allows violent websites through. And I decided that, telling them with words wasn't working. I was going to show them with pictures. So we brought them upstairs and led them through a little slideshow of the everybody doing their top 10 list, and we had in excess of 100 of these really, really, really nasty websites. The pornography was the least of it. It's Holocaust denial sites and other stuff that was just unbelievable. It got the point across because the defects got fixed very quickly after that. I don't think we could have accomplished anything of that same scale with a pre-designed test. So I think there are some cases where having an exploratory test charter is just really the right way to go, and you'd be trying to put as the cliche goes, a square peg in a round hole by trying to pre-design the tests. Okay, so just to kind of restate this, what you see there is your ducks in a row. Sorry, I couldn't resist that. Those said ducks are walking across some bricks in front of the Kremlin, if I remember right. That's where that is. They're brass ducks, by the way. That's you're wondering, what duck is that color? One's made of brass or that color. So anyway, I'm pretty convinced that exploratory testing was invented by the first programmer. I believe if you go and look at the first quote unquote bug report, which was written by Grace Hopper, if I'm remembering, that has the little moth taped to it. There's probably evidence there that was found via exploratory testing of some kind or another. So that's, there's various myths around exploratory testing, myths about how perfect and invincible and wonderful it is, and myths about how useless and extraneous and harmful it is, and those are on both sides wrong and get in the way of using this best practice effectively. So I consider exploratory testing to be essential, but not sufficient by itself to achieving a good, successful test approach. And through the use of techniques like time boxes and charters, we can keep it pointed in the right direction and use that to find bugs that other techniques would certainly miss. All right, great. So I am going to go ahead and put up the advertisement for RBCS here while we do the Q&A session, and I've got a question already coming in here from one listener, and I'll take questions from the live audience as well. Before we do start, the advertisement is up to remind you that we do these free webinars as a service because we're not just for-profit company, but we do need to keep the lights on. So if you're looking for testing, expert services, or consulting with respect to software testing, then please let us know. All right, so I'm going to start with the question from Martin Fenelon, who had submitted this via email, and I said, hey, why don't you join the session, and then you can ask it live, and here he is. So thank you, Martin, for this. Now let's see, it's still trying to get my head around this Zoom interface, so I'm assuming I'm seeing the whole question. Martin says, one of the challenges that I've encountered with exploratory testing is the reluctance of testers, especially from the business user community, to document the test case as they proceed through testing. There is often the intent to document those test cases and data sets that uncover an issue, but they wait until an issue occurs to decide that it needs to be documented. At that point, many of the key details are forgotten, making replication of the issue and verification that it has been resolved difficult. My solution to date has been to provide easy to complete paper forms that testers can fill in as they go without having to leave the application under test. We collect all of these each day, including ones where no issue is found. In addition to having a starting point for issues that are found, we screen the successful test cases. We review them to see if there are any reasonable business cases that we should add to our test bank. Presumably, Martin means is pre-designed, written, or automated test bank. And it says this approach gets a lot of resistance. Any recommendations on, and then the interface seems to have cut off the rest of the question here, but I think it's pretty clear what the question is. So Martin, I think that the paper-based approach is fine. Of course, it kind of depends on the decipherability of people's handwriting. If people had to read my handwriting, they would be very unhappy about that. I like to consider my handwriting a form of data at rest encryption that's built into my right hand. I actually thought I had really the best encryption, but I was working with a guy 2 weeks ago who showed me his handwriting, and I said, yep, that's right there with hieroglyphics. It's completely inscrutable. But so, I mean, other than the possibility of difficulties reading, the other bit of resistance you might get with that is that it might seem like dinosaur era kind of thing. So that tool that I mentioned, the Rapid Reporter tool, is one that can be used in real time to enter notes on a PC. And I've had people say that they use just Notepad to do that as well. Now, of course, this ability to take notes is not going to completely solve the problem, because if we're talking about business users doing testing, those people would be what I would call amateur testers. I don't mean amateur. The word amateur sometimes gets confused to mean incompetent or half-assed or something like that, but it really just means somebody who does something because they have some interest or concern or love for something involved in it, like amateur chef who likes to cook or likes to eat. Doesn't mean bad, it just means that they have a specific interest that they're pursuing, and things outside of that interest are unlikely to get a lot of attention. So I'm something of an amateur chef myself, and I can cook up reasonable dishes of various kinds. But one thing that I'm usually completely unconcerned with when I'm cooking at home is when exactly dinner is going to be done. That would make me absolutely incompetent in a restaurant, because when people come into a restaurant and order dinner, they want it to arrive at a particular time. When I start cooking, when the dinner is going to be done kind of depends on whether I decide to have one whiskey or two whiskeys before dinner. All right. So, that just rule me out right there as a chef. Now, I think the same thing is going to happen with your amateur testers, in that they're not going to be, it's difficult to get amateur testers to get really excited about things like bug reporting and coverage analysis and traceability and writing up test cases and so forth, because that's not why they're doing it. That's not what they care about. What they care about is, does that thing that I'm going to try to do with the software work? And everything else is just sort of an extraneous detail to them. So I think, Martin, you may find that regardless of how you try to solve this problem, that you are, as the economists put it, pushing on a string. That it's difficult to affect lots of changes unless you can figure out some way of convincing them that it is actually connected to the thing they care about, the usefulness of this particular feature that they're testing, to do things like write good bug reports and document their tests properly and capture traceability back to the requirements that are associated with the tests and so forth. So I hope that has adequately answered the question, Martin. All right, we now have no open questions. So I'll take questions from the live audience here if anybody has one. Yeah, Geoff.
As I explained to you earlier on, I've been off the radar a little bit.
Mm-hmm.
But I do recall in years past going into lightsaber duels with the exponents of exploratory testing.
Speaking of Jedis, yes, lightsaber duels.
Yeah.
Yeah.
And as soon as I made mention of counted test cases in both, I had 20 people leave across tables with nostrils, eyes blazing, my lungs out. Since those been going back 7 years now, there seems to have been a trend to more institutionalize exploratory testing as a fairly useful tool within the testing lifecycle. And I never ever denied that. I mean,
Yeah.
The traditional approach, but also go back into your exploratory approach. I'm sorry, I did miss the first part of your session. Right? But how do you see that exploratory testing has now become kind of embedded in the software and testing lifecycle?
Well, yeah, so has it become embedded now, finally? So the good news, Geoff, to your earlier point, is I think that some of the religious warfare that was going on in the early 2010s, late 2000s, early 2010s has abated. I think some of the more, let's just say, obstreperous voices of that era have kind of taken their show off the road for various reasons and aren't off stirring the pot as much. So I've noticed a real significant decline in, like when I first gave this presentation, it was about 5 or 6 years ago, and it was definitely knocking the wasp's nest out of the tree. There were people who were quite unhappy about it. Now I think it's fairly, what I've said is to some extent uncontroversial on that side, the advocacy side of exploratory testing. I think now we have the opposite problem though, which is the people running around saying, well, automate everything, right? We're going to have these automated build and delivery pipelines. We're going to have all these automated tests, and then those automated tests by themselves are sufficient to deploy software into production. Now, I think that's fine if it's okay to deploy something into production that breaks production, and you can recover from that very quickly without any sort of permanent harm, right? And there are some various mechanisms used to try to do that, like, for example, A/B testing, where you go into production in a very limited way and you're watching for something really severe to break out. But, still, you would hardly want software to be released for, say, self-driving cars or nuclear medical devices, where the only testing that it had been subjected to was automated tests that could run in the space of a 2-hour-long build or a 15-minute-long build or however long the build is, right? This idea, when people say, all we need to do is automate everything, or we're going to focus on 100% test automation. Effectively, what they're saying is anything that cannot be automated, we're not going to test. And that is not by any means a risk-based approach to thinking about testing, because you want to start with the question of what's the likelihood and impact associated with particular kinds of problems, and determine what the level of risk is, and let that determine what you test, right? And the question of whether it's automatable or not is a tactical question. And this idea of letting a purely tactical question drive a strategic decision about what is appropriate coverage is just completely ass backwards, right? And it is somewhat alarming to me that has gained so much traction. I think there was what I consider to be very counterproductive attempts to take on that argument by trying to say, well, automated testing isn't testing, it's checking. And then immediately we get into this picayune how many angels on the head of a pin, definitional discussion about checking versus testing and so forth. And it distracts us from the bigger point, which is that we are allowing tactics to determine strategy and not the other way around, which is just completely wrong. So I am a bit concerned about that. I'm relieved that we aren't still stuck in those really incredibly tedious religious wars that we had for that 10-year period of time. But I'm worried now that another sort of DevOps, it's not really religion, but just sort of article of faith here about everything can be automated, and people not thinking through implications of that. I'm a little worried that that has kind of seized the day.
I think like using some of the claims of the automated tool vendors would have led us to believe that we could automate between 80% of our test.
Yeah, but this isn't vendor driven, Geoff. This is a lot of this is associated with open source now, so we don't have the convenient scapegoat of the vendors are telling people big stories about the capabilities of their tools. Not to say I'm totally with you that happened. I know that happened.
Well, we found it then the pendulum sort of kind of swung the other way.
Yeah.
I guess my observation is that some of the promises that perhaps made 20, 25 years ago are only now becoming technologically possible. I'm not suggesting that we can
Yeah.
100%, but it certainly seems we can automate more productively than we ever have been in the past. Is that correct?
Oh yeah, that's definitely true that the amount of automation that we can do. I think partly this is a Moore's law thing that there's the amount of memory and CPU capacity and network throughput and so forth, allows for things like parallelization of testing and so forth. And so the number of tests that we can get done in a practical period of time has really gone up. I also think that thanks to whoever it was that came up with the test automation pyramid, I always blank on the fellow's name. Was that Cohn? Oh, okay. So thank you, Mike Cohn. That's a really important insight, because I think that all too often in the late 1990s and early 2000s, it was test automation snow cone, right? I mean, there's heavy emphasis on automation through graphical user interface, and that's just dumb. I mean, those are big, slow, brittle tests typically, and if you're saying I got to do a bunch of that rather than a bunch of unit tests, that are fast and tend to be more maintainable, I think that was an important insight. But it's an Egyptian pyramid, not an Aztec pyramid, right? The difference I'm saying, right? The Aztec pyramid is flat on the top, right? Which basically would mean no automated system tests, right? And I think you still need to have those. Todd, you wanted to add something?
Yeah, and also the Cohen's pyramid still has manual testing as the extra file at the top, because you need to have manual tests. Automating testing, yes, certainly we can automate more than we could before, but it means there's more software development.
Yeah,
if you try to automate everything, that means that you're effectively saying any test you can automate, we're not going to know.
Yeah.
But tests that you can't automate are not doing that.
Right.
And particularly tests that have to do with how users use it.
Yeah.
If you have only automated users in the system, then you can have
that is an excellent point, Todd, that if I am talking about a microservice, the only thing that it interacts with is other microservices and other applications that are calling it, then the only way with which it will receive and dispense information is through that API, right? So then, yes, that's a special case where, sure, you could say, you know, that's something where I might want to do 100% automation. I would say even there, though, if you're in a situation where certain kinds of asynchronous events can occur that disrupt that communication, you're probably still going to want to have some amount of manual testing of that, right? Because what if that microservice is in the middle of communication with some other application and the connection goes down? Or it's a communication that's happening across the internet and the topology changes, right? So now the packets are getting rerouted and stuff starts showing up in different orders. You know, that's not going to be something that's going to be easy to do with a purely automated approach, right? Especially purely on, yeah, yeah, and that's again where the exploratory type of techniques where you're like, well, what if I try this? What if I try that? You know, so yeah, I just think that it's difficult to imagine a place where you'd be absolutely 100% automated tests would achieve adequate coverage. And certainly if you're talking about an app that runs on a mobile phone or a web-based application that runs in a browser or something like that, interacts directly with the user, yeah, that's just craziness. Yeah, great.
One other comment is you mentioned about perception and GUI tests are always flaky and unstable. Depends on how they're designed.
Well, yeah, I mean, I agree that there are degrees, but I think as a general statement, you can say that GUI tests are much more apt to be brittle and to break than a test that's going through an API, right? Just because APIs, once defined, tend to accrete so much stuff around that API that nobody wants to change the API. They may change the implementation of the code underneath the API. Changing the API is going to break a bunch of other stuff and ripple through, and the developers aren't going to want to do that. But with UIs, you know, you have to be able to change that. Yeah, but you know, yes, yeah, yeah, but even my clients that have done, I think, the best job of building maintainability into their GUI scripts still have more maintainability challenges with their GUI tests than they do with their unit level tests and their integration level tests that work through APIs. I think it's inherent. Yeah. And the other thing too is that they are just going to be slower, right? You're going through a GUI, it's going to be slower, and that means if you're going to try to include those into build and delivery pipelines, you're going to have this Hobbes choice kind of thing going on there of like, I can put as many of those tests in there as I want, but do I want a build that takes all night to complete because of the automated GUI tests, right? Or longer. I mean, I've had clients tell me about they have parallelized one client in particular I'm thinking of. I visited last year to look at their automation. They had parallelized racks of tests going because it's hardware software system. They had like 7 or 8 of these things, and all of them took at least an hour to an hour and a half to run through their complete bank of automated tests. And there was one of them that took 36 hours to get through it. You know, so those kinds of things. I mean, even if you've solved the maintainability part, you still don't want to have something like that on the critical path for completion of a build, right? So you have to think about, well, how do we want to handle this? You know, what they did I thought was pretty smart was that said they had these separate racks and builds got installed and tested there. Now they hadn't solved the automated deployment from the build environment into the system test environment yet, which they needed to do, and they hadn't solved the automatic launch problem yet because it still was a manual launch process. But you know, they were making progress. But anyway, I've kind of digressed there. But the point being that yeah, automation is great, and I mean, I started as a test automator. I love automated tests. I think they're very good and valid things, but they are, you know, they're basically their verification, you know, and anything that drives out manual testing is, I think, very smart. All right, any other questions, comments? No, it's late, so we can close this up. All right, so a few final words here. We do run these webinars once a month, so if you check our website, rbcs-us.com, and sign up, you'll hear about the webinars, as well as receiving our free newsletter, which gives you valuable discounts on our consulting and training services, and also information about what we are up to. You can see all of our social media coordinates displayed up there. If you're interested in connecting with me on LinkedIn, I always accept connections from people who've attended the webinar, so don't worry about maybe I report you as a spammer or something. The YouTube channel has just tons and tons of videos on various things. All the recorded webinars get posted out there. There's going back 10 plus years. There's probably 20 hours of videos just on risk-based testing, for example. So yeah, there's all sorts of stuff available for you for free on those various coordinates. Do remember to check your email over the next few days, because you may be the lucky winner of the free e-learning course. Somebody does win every month, so watch for that. And then finally, podcasts. If you'd rather listen than watch the podcasts or webinars on the YouTube channel, you can subscribe to the podcast, and you can download them and listen to them. And some of these webinars are very suitable for podcasts such as this one. And once again, we do offer these free resources as a service to the software testing community, because we are a not just for profit company, but we do need to keep the lights on. So if you feel that these webinars demonstrate insights into the kinds of testing problems you face, please make RBCS your first choice when you need consulting, expert services, or training. This concludes the webinar, and thank you all for joining us today.